Assalamualaikum. Hi everyone. So today I want to share about Newton's universal law of gravitation and circular orbit. So firstly, before we learn about Newton's universal law of gravitation, we have to know about gravitational force because this is the force relate to the Newton's universal law of gravitation. Okay, so the gravitational force is actually one of the four fundamental forces found in nature. So there are four fundamental forces, which is strong nuclear force, weak nuclear force, electromagnetic force, and the last one is gravitational force. And the gravitational force is the weakest among the four fundamental forces. Okay, and this force acts at a distance without physical contact, and it always attractive and just depend on the mass involved and distance between the objects. Okay, so Newton's universal law of gravitation states that every particle in the universe that have mass, okay, attract each attract every other particle with a force along a line joining them. Okay, so the force is directly proportional to the product of their masses, which is F is directly proportional of M1 and M2. Let's say this one M1, the second one is M2. Okay, so the force is directly proportional to the product of their masses and inversely. Okay, so the F also inversely proportional to the square of the distance between them. Okay, so this is a gravitational force. So the first object, okay, pose force to the second object, which is at the different opposite direction, but the same amount of force. And the amount of force uh, actually is given by F equals to G M1 M2 over R square, which is G is the gravitational constant, M1 refer to the mass for the object 1, M2 refer to the mass of the object 2, and R is a distance between these two objects. Okay, so if one object, okay, has much less mass than the other, it will be accelerated more. So meaning that this one is smaller and is bigger. So this one is will move faster. Okay, we accelerate more compared to the massive object lah. So usually we set more massive object as M, capital M, and the less massive object as a small m. Okay, so this one in the notation, so we use capital M, this one small m. Okay, okay, so the distance between two masses, actually, or two objects, is taken from the center of the mass for both objects. So that's why this is the distance that we consider in this law. Okay, so the magnitude of force between the objects, okay, is same as I mentioned just now, and we calculate using this equation lah. So this equation is relate to the Newton universal law of gravitation. Okay, the m is small m, so this one is capital M. So the gravitational force is actually very small value. It has very small value. So let's say uh, our body weight is actually the force of attraction um, of the entire Earth on Earth. Okay, so with mass of the Earth is 5.98 times 10 to the power of 34 kg. Okay, so we on the surface of the Earth. Okay, so let's say we jump. Okay, we falling, okay, to the Earth. Okay, so the force acting on Earth actually gravitational force. Okay, so gravitational force. Okay, so let's say this is ground. Okay, let's say this is ground of the Earth. Okay, let's say we are here falling down. Okay, falling down. Okay, falling down, which is, let's say, the distance is uh 20 cm. Okay, 20 cm, very short, a small distance only. Okay, so we falling down to the surface of the Earth. Okay, so the only force acting on Earth is actually gravitational force. Okay, so gravitational force from the entire Earth on Earth. Okay, at the same time, we also impose the gravitational force to the Earth, the same magnitude but in different and opposite direction. Okay, so when we consider ourselves, okay, so the only force acting on our body, just if we ignore the air resistance, so the only force acting on our body is a gravitational force. So based on second Newton law, the net force on our body is equal to ma. Okay, ma. In this context, the acceleration we call gravitational acceleration. We replace with the g. Okay, so based on second Newton law, the only net force acting on our body when we're falling on the Earth's surface is gravitational force. So the gravitational force causing we um, accelerate toward the surface of the Earth. Okay, so from second Newton law and gravitational Newton's law of gravitation. So what we can say actually, so F on our body is equal to mg. So the net force only acting on our body is come from gravitational force. So the gravitational force is from F equals to, which we know just now I have mentioned, equals to g, gravitational constant, and between two objects and distance between them. So for this context, okay, because the only force acting on our body is from gravitational force, so this force causing we accelerate to the surface of the Earth. So that's why g m Earth mass of our body divided by r square is equal to mg, and our gravitational acceleration is equal to g m over r square. Okay, so we substitute the value of Earth mass, which is 5.89 here. Okay, so okay, then we know the radius of the Earth. So the average radius of the Earth 6.38 times 10 to the 6 meter. So we just because the distance is very small from surface to our body, so we just ignore the distance. So we just take the radius of the Earth. Okay, then we substitute the gravitational constant here. So we will obtain that g is 9.8 meter per second square. So this is the gravitational acceleration on the Earth's surface. Okay, so for the part 2, okay, so we will learn how the gravitational force will be applied to explain the how the Earth orbiting the Sun and how the Moon orbiting the Earth. Okay, so that's all for part one.